Hello guys and welcome back. Today we will be discussing again some very good questions from Maths Explorers. And guys, this is the question today that you can see right now on screen. A really good question which I had to obviously bring. So without further delay guys, if you want, you may try this question out yourself once. I will wait for a few seconds and then start solving this. Okay guys, so I guess now we can proceed to solving this. So the first step to actually solve this, like if we take a small overview of the question once, then it is f of n as given to be equal to tan inverse of this thing, which is obviously looking like it's a telescoping series. And g of x is given as tan inverse of root under 1 plus x square minus 1 by x, which is pretty simple to solve. Okay, I hope you can already guess how, but we will solve it later. And on its basis, which of the following statements are true? So we have to find out which of these statements are true, testing each of them. Okay, so pretty long this question is going to be, because you can see it is f double dash x here, so maybe a little bit of calculation, but anyways we will solve it. Okay, so I hope you have seen the question guys. So right now I will change the screen and start solving. Okay, so our f of, okay wait, before writing f, actually we had this expression tan inverse of the expression within f function. Okay, it was 2r divided by r power 4 plus r square plus 2. Okay, so type of, actually to simplify this thing, like we will observe the denominator. Okay, so I hope all of you will know this, like it's a very famous result actually that is used in many sums. And otherwise, if you have a problem determining this, what you can do is you can go for a tan inverse 1 by a minus 1 by b, but that would be actually too tedious. Okay, this is something that you guys should know, I guess. Like this is can be written as r square minus r plus 1 into r square plus r plus 1. I hope everyone will know this. This is very common. Okay, I don't think there is any need to derive this directly, because this thing is really like, maybe when I bring in my synopsis series, I will bring it soon or later, maybe within 3 months. It will take time. I will bring out synopsis for all chapters. When I bring it, I will include this formula in basic maths maybe, because this is really like something that you will need. Okay, I have seen this in many sums, so you should remember this rather than deriving it in the exam hall. Anyway, so we can actually write this thing as your tan inverse of, like this thing in the denominator can be factorized like this. And if you actually notice, your this r square plus r plus 1 minus of this thing, okay, first this bracket minus this bracket actually gives us 2r. So it's basically your tan inverse of 1 by r square minus r plus 1 minus of tan inverse of 1 by r square plus r plus 1. Why? Because this thing is tan inverse of, if I want to like elaborate, this is tan inverse of a minus b by 1 plus ab. Okay. Okay, wait, okay guys, I'm really sorry. I just said something wrong. Like, I'm a little bit drowsy, okay, right now. So maybe I just spoke something wrong. Like, this is r power 4 plus r square plus 1. Okay, only plus 1 and actually 1 plus ab. I'm really sorry. Like, how could I make this mistake? Anyways, I hope you have understood. Okay, and don't worry, I will include this in my basic math formula sheet also. Okay, so things are coming, so you have to just wait. Many things are coming ahead. Okay. Anyways, tan inverse a minus b by 1 plus ab. Actually, that one adds up and r power 4 plus r square plus 2 comes. Initially, on the multiplication of these two brackets, it will be r power 4 plus r square plus 1. And then after this is coming. And here, if you want to know what are a and b, then your capital A is equal to r square plus r plus 1, and your capital B is equal to r square minus r plus 1. Okay. Yeah, so cool. I hope this is done. So right now, because this is a telescoping series, you can observe the terms and see, right? So adding this thing up will not be at all a difficult task, because terms will start cancelling. So this is sigma r equals to 1 to n inside the bracket tan inverse of 1 by r square minus r plus 1 minus tan inverse of 1 by r square plus r plus 1. Like these questions are actually really common in JEE Advanced. Okay, many a time this type of tan inverse manipulation has been asked. So really relevant stuff. Okay, you should be able to solve this actually. This is a difficult, like not very difficult question, lengthy question, but yeah, I will maybe not rank it as difficult. It is in between, somewhere in between medium and difficult. Okay, so like to solve this guys, I hope no difficulties, because if you put tan inverse 1 and r equals to 1 2 and so on, you will see that this term will remain in the first pair and the last term will remain in the last pair. Rest of all the terms are getting cancelled. I'm not going into that. So this will actually come out to be tan inverse 1 directly, so pi by 4, and this thing is your tan inverse of n square plus n plus 1. Okay, so f of x is actually right now ready with us. Okay, wait. Actually, it was asked for f of n, but we had to convert it to f of x. Okay, no issues. F of x is equal to pi by 4 minus of tan inverse of 1 by x square plus x plus 1. Yeah, I hope this is correct. So this is your f of x finally, or f of n, whatever you want to say. Okay, so this is f of x, and now to simplify g of x. G of x, it was given to be equal to, I will write the expression, tan inverse of root under 1 plus x square minus 1 by x. Okay, so guys, like there are a whole lot of numerous methods to solve this, many methods. Okay, like I will go with the most popular one, maybe taking x equal to tan theta. If you want, you can rationalize this also and do, but that will be tedious. So tan inverse root under, this is actually directly copied from your NCRT. Okay, I will not say copied, like it's a very common question actually, but this is directly available in your NCRT. And therefore secant square theta is 1 plus tan square theta, so tan inverse of secant theta minus 1 by tan theta. So further manipulating, tan inverse secant theta is 1 by cos theta, so 1 minus cos theta by sin theta. And now, like, what should I say? Really simple stuff. 1 minus cos theta will be 2 sine square theta by 2. This thing is very obviously 2 sine theta by 2 cos theta by 2. So this and this will get cancelled, and you will have tan inverse tan theta by 2, which is theta by 2, or half of tan inverse x. Okay. So g of x comes out to be half of tan inverse x. This was pretty simple. There is another method also, like if you want to have some really lengthy calculation in your exam hall, then you may go to rationalizing this, then it will also come. Okay. But anyways, we will go with the simplest one. Okay. So I hope things are clear till here. So guys, now let's go on into our options one by one. Okay, so our option number 1 basically says that integral 0 to 1 4 times gx dx. We have to find this. So this is integral 0 to 1 4 times gx dx, meaning 4 and 2 will get cancelled, so 2 outside, I'm taking it outside, and this will be tan inverse x dx. Okay, so like evaluating this is not a very difficult task, I hope. Like this will be absolutely simple by parts. Here there will be a 1, and this is your tan inverse x, right? So you take this 1 as v and this tan inverse x as u. So this will become 2 times of, if we do the integration for v, u integral v dx, so x tan inverse x, and inside you will actually have integral. Okay, we will also put this limits 0 to 1, and inside you will have integral 0 to 1, and this thing will be tan inverse x differentiated, so x by 1 plus x square dx. And now this is really piece of cake stuff. This will come out to be 1, so pi by 4, and tan inverse 0, obviously it will become 0. And this thing is half ln 1 plus x square, right? I hope I don't have to explain. 1 plus x square as t, this will come out to be dt by 2, so half ln 1 plus x square. And this goes up to 0 to 1. So if you evaluate this thing, this will be 2 times in pi by 4 minus of, and here if you put the values, this will come out to be half ln 2. Other term will be 0, okay? So I guess this will on multiplying become pi by 2 minus ln 2. And yeah, this was the value that was given. So your option A comes out to be correct. Okay, option A is absolutely correct. So I hope this was done. So guys, now let's move on to our option number B. Okay, so in our option number B, actually, this is going to maybe cost a lot of calculation. It was told that we have to find f double dash 1. Okay, so a little bit of calculation is there, but don't worry, we can shorten it up also. Actually, the calculation won't be too much because many terms in it would look like it's a very big fraction when you, because it's a quotient form, right? Tan inverse of 1 by, I guess it was x square plus x plus 1. So when you differentiate that thing, actually it will be quotient form, but many a thing would get cancelled also. Okay, so it won't be that big. I have calculated myself, so I know that. Anyways, f of x was your pi by 4 minus of your tan inverse of 1 by x squared plus x plus 1. So let's do a small thing. Let's set u of x. I will say let u of x equal to x square plus x plus 1. So if we differentiate f dash x right now, keeping this u of x, I mean it is now pi by 4 minus tan inverse 1 by u of x. Okay, this is just small notation playing with so that we can make the calculation a little bit simpler. So minus u dash x by 1 plus u squared x. Very simply, like really simple differentiation. Okay, and I'm sorry, I hope this is a little bit curved here because my head was this side, so this became curved. Okay, just take a note. So guys, is I calculate f dash x, actually, like this will actually come out to be, if I want to simplify this, this comes out to be 2x plus 1, and okay, wait guys, I actually did a small mistake. Don't take u of x as x square plus x plus 1, take it to be 1 by x square plus x plus 1. Okay, that is actually better, otherwise like this will reduce the calculation a further step more. Don't do that. Okay, take u of x to be this entire thing, so actually this is tan inverse of u of x. Okay, so if we evaluate this, this will be 2x plus 1 whole divided by x square plus x plus 1 whole square. Like this can be differentiated using quotient form. I am directly writing it, okay, because I have calculated it. So this will be 1 plus 1 by x square plus x plus 1 whole square. And that's why I said actually you won't have calculation. You can see a lot of cancellation is going to happen. So if you evaluate, this will come out to be 2x plus 1 whole divided by x square plus x plus 1 whole square plus 1. Okay, this is your f dash x, but we are not still done. We have to find out f double dash x also. So let's quickly find out f double dash x. A little bit of calculation. F double dash x is going to be 2 times of differentiated this. Okay, let's do it. Okay, or guys, I like, let me do one thing. This up till this step I have done. After this it will just be one step of quotient rule. Okay, so what I'm doing is I am leaving this step because it's unnecessary calculation I have to do, and I hope you can understand. Okay, so I'm leaving it. You just calculate, and let me tell you, I have already calculated it, so no issues. F double dash 1 will actually come out to be minus 17 by 50 itself. Okay, like see, it will be looking a little messy in the beginning, but don't open any brackets or square this x square plus x plus 1 thing up. Keep where whatever it is, don't multiply too much, just keep it in a whatever factorized form it is, and then just put 1. You will get the answer automatically. No issues will be there. Okay, and this will actually come out to be correct. Your option B will also be correct. Okay, I just left the calculation, guys. I hope you don't mind. So this is option B done. Now let's go on to option number C. Okay, so option number C says that we have to find the solution to the equation g of x is equal to f of 1. So g of x was half tan inverse x, and f of 1, very simply, if we put f of f equal to 1, it is pi by 4 minus tan inverse 1 by 3. Absolutely, no doubts. So if we want to kind of evaluate this, the only productive thing that I can right now see is tan inverse x multiplying throughout with 2. This will become pi by 2 minus 2 tan inverse 1 by 3. Okay, this is type of a inverse trigonometric equation, you can say. Okay, so this is it. Okay, so now let's do one thing, guys. This is tan inverse 1 by 3, right? So to simplify things, I will take theta to be equal to tan inverse 1 by 3. So this thing becomes tan inverse x is equal to pi by 2 minus 2 theta. So very simply, x will be tan of pi by 2 minus 2 theta, or cot 2 theta. So if we want to calculate cot 2 theta, I guess it will be 1 by tan 2 theta. So if we want to find out tan 2 theta, then tan, like from here, tan theta is equal to 1 by 3. So tan 2 theta will be 2 tan theta by 1 minus tan squared theta. So this will be 2 by 3 into 9 by, I guess, 2 by 3 into 9 by 5, I guess it's coming. Wait, I will check. Okay, I am sorry, this is not 4 by 9. This is 1 by 9. That's why I was thinking why it is not coming. Anyways, 2 by 3 into 9 by 8. So this thing, I guess 6 by 8, so 3 by 4. That means this will be 4 by 3. So x equal to 4 by 3 will be the solution for this equation, which is also absolutely correct. So C also is correct. And now let's move on to the last option D, which I also guess will be correct because all are coming out to be correct. Okay, so this is your option number D, which is limit n tends to infinity n square times s minus fn, that we have to find, where s is equal to sigma r equals to 1 to infinity tan inverse 2r by r power 4 plus r square plus 2. So this is basically nothing but your limit n tends to infinity f of n. Okay, and we obviously know that your f of n was pi by 4. I'm sorry if this looks like x, it is not x, it is n. Okay, and this thing pi by 4 minus tan inverse 1 by n squared plus n plus 1. Okay, so like I hope this is very simple to solve. If we evaluate limit n tends to infinity f of n, like it is s minus f of n, right? So if you actually tend this particular expression, this complete expression to infinity, then you will see n square plus n plus 1, all the terms are present in the denominator. So this will very purely go off to 0. So actually s is pi by 4. Okay. So limit n is tending to infinity. I missed the n square. S minus of f of n, this is coming out to be equal to limit n tends to infinity and n square tan inverse of 1 by n square plus n plus 1. Okay, like guys, see, don't treat this limit and this limit as same. Okay, it's like limit n tends to infinity n square and inside there is another limit. Please be careful of this, you might confuse. Anyways, so guys, after this things are pretty simple because tan inverse argument that is present is actually like the argument of tan inverse is going to 0. So we can simply replace the argument tan inverse with this complete thing. So this is limit n tends to infinity n square by n square plus n plus 1. So very simply, like if we divide by n square, then your answer for this question will be 1 because its limit n tends to infinity. And it was also given, so option number D becomes also correct. Okay, so without any doubt guys, the correct options for this question are A, B, C and D. All the options are correct. Okay. Anyway, so guys, this will be the end for today's video, I guess. I hope you have liked this question. Really good question, kind of. Okay, like manipulative question. Actually, this is required for 2026 people because your paper will be set by IIT Roorkee. So your paper will be really manipulative. Okay, and with manipulative, I mean calculation plus intelligence. So, anyways, like be ready with whatever you have. Okay. So guys, that's the end for this video. I hope you have liked this video. If you have liked my channel, do like, share and subscribe. Any doubts, anything, do come out in the comment section and do join my Telegram broadcast channel for further updates and questions. Okay, that's it for today guys, I hope. Thanks for watching.